So students, we are doing about the methods of preparation of alkanes. Already you have got one method. You can prepare the alkanes from sodium salt of carboxylic acid, and another method, that is number 2, by reduction of alkyl halide. By reduction of alkyl halide. This is another method. Alkyl halide means haloalkane. I mean, when alkyl group combine with halogen, halogen means fluorine, chlorine, bromine, iodine, then that compounds are called alkyl halide or haloalkanes. From this haloalkane also you can prepare the alkanes. What you have to do? One alkyl halide you have to take, and then you have to do reduction of that alkyl halide, then it will convert it to alkane. So what is reduction? As you know, oxidation means addition of oxygen and reduction means addition of hydrogen. So by adding hydrogen with alkyl halide, you can prepare your alkane. For example, this is the general formula of haloalkane. When alkyl group combine with halogen, then the compound is called alkyl halide. R is called alkyl group, X is halogen. This is called alkyl halide, or they are also called haloalkane. When you add hydrogen, addition of hydrogen is called reduction. So you have to apply hydrogen, and you have to apply some reducing agent, I mean which helps in reduction. This is one of the example of reducing agent, lithium aluminum hydride. This is one example of strong reducing agent. Or you can apply this one also, sodium ethanol C2H5OH. This also acts as your reducing agent. Any reducing agent you can use. Either you can use lithium aluminum hydride or sodium ethanol you can use. So when this alkyl halide combines with hydrogen in presence of this reducing agent, then what happens? The halogen is removed from the compound. I mean, from alkyl halide, this X will be removed and the X will be replaced by one hydrogen. So that's why it is called reduction. So halogen will be removed. When halogen is removed by hydrogen, then it will convert to RH, which is called alkane, and the X, I mean removing halogen, combined with another hydrogen, it produces the side product HX. So this is another method of preparation. By doing reduction of alkyl halide, you can convert to alkane. For example, suppose your alkyl halide is CH3, R is CH3, and your X is suppose chlorine, halogen, and then it is called methyl chloride. When you do reduction of methyl chloride, I mean when you add hydrogen in presence of reducing agent like sodium ethanol or lithium aluminum hydride, then the chlorine will be replaced by hydrogen. So the electronegative element chlorine is removed from the compound. Removal of electronegative element is also called reduction. So there are different your definition of reduction, either addition of hydrogen or removal of electronegative element, both are called reduction. So that's why this electronegative element is removed from the compound, and that electronegative element will be replaced by hydrogen. I mean the CH3 will combine with one hydrogen, it convert to CH4, and side product will be HCl. So by doing this you can prepare methane. Similarly, suppose your alkyl group is ethyl group, and which is called ethyl chloride. When you do reduction of ethyl chloride, I mean when you apply hydrogen in presence of the reducing agent lithium aluminum hydride, then the chlorine will be replaced by hydrogen. Same method, then it will convert it to CH3, I mean C2H6, which is called ethane, and side product will be HCl. You can take halogen as bromine, iodine also. So if you want to prepare methane, then you have to take one carbon here, chloromethane you have to take, I mean methyl chloride. If you want to prepare ethane, then you take ethyl chloride. If you want to prepare propane, you take propyl chloride. So by taking different alkyl halide, you can prepare different alkane. So depending on the number of carbon present in your alkane, what alkane you want to prepare. Suppose you want to prepare propane. Propane contains 3 carbon. If you want to prepare 3 carbon alkane, then you have to take 3 carbon alkyl halide here. I mean, you have to take propyl chloride. If you take propyl chloride, you will get propane. If you take butyl chloride, you will get butane. So that is why by using this method, you can prepare any alkane as required. So this is another method for the preparation of alkanes. Now, number 3 method, by Ur's reaction. Ur's is the name of scientist. This is a very important method, by Ur's reaction. In exam also you may get the question, write the Ur's reaction. So you can write the reactions. Actually, Ur's reaction, Ur's is the name of the scientist. He carry out one reaction, and by doing this reaction, you can prepare the alkanes. So what is Ur's reaction? Here also you have to take some alkyl halide as you have done in second method. For example, this is one of the alkyl halide, methyl chloride. When the methyl chloride is react with sodium metal in presence of one catalyst, dry ether, you have to take ether compound. Ether is one of the organic compound, and that ether must be dry one. It should not be moist ether, I mean water should not be present. So when haloalkane is react with sodium metal, to do this reaction, here you have to take 2 haloalkane. You can write 2 haloalkane like this, but to understand the reaction, I will write 2 haloalkane like this. This is one of the CH3Cl. So one CH3Cl is here, another CH3Cl is here. Then what happened? When this alkyl halide methyl chloride reacts with sodium metal in presence of dry ether, then the sodium is, metal, chlorine is non-metal. Metal and non-metal always combine to form some ionic compound. So that's why this sodium combines with this chlorine. They will form sodium chloride. And this CH3 combine with that CH3, it will produce the alkane like this, CH3, CH3. I mean, you will get the ethane. And what about the side product? Side product will be NaCl, twice NaCl. To balance the reaction, you have to put 2 sodium, then the reaction will be balanced. So, what is Ur's reaction? When alkyl halide is react with sodium metal in presence of dry ether, then an alkane is produced, and this reaction is called Ur's reaction. Always dry ether is used as catalyst in Ur's reaction. Similarly, this is another example of haloalkane, CH3CH2Cl. When you react with sodium metal, and this is another haloalkane, both should be same. You can take different haloalkane also, but here I have taken similar haloalkane. Then here also sodium combines with chlorine. Actually, for the combination, chlorine I have written this side so that you can combine them. You can write CH3CH2Cl also, in that way also you can write. So this sodium combines with chlorine, they produce sodium chloride. Catalyst is required dry ether. Side product will be twice NaCl. Now this CH3CH2 combined with this CH2CH3, you will get 4 carbon alkane, and the 4 carbon alkane should be like this, CH3CH2CH2CH3, which is said to be butane, 4 carbon present. So in Ur's reaction, always you will get the double number of carbon of alkane as present in your alkyl halide. If your alkyl halide contain 2 carbon, in product side you will get 4 carbon. If your alkyl halide contain 1 carbon, you will get double number of carbon, I mean 2 carbon you will get. So you can prepare the alkane in this way. So ethane you can prepare, butane you can prepare, but if you want to prepare propane, propane contains 3 carbon, na? Then you have to take different haloalkane. Otherwise you don't get propane, because 3 carbon, I mean it is odd number of carbon. But this Wood's reaction method is applicable for preparing, I mean suitable for preparing those alkane which contain even number of carbon atom. See, ethane contain 2 carbon, even number, butane contain 4 carbon, even number, hexane contains 6 carbon, even number of carbon. For that type of alkane, this reaction is suitable. But if you want to prepare propane, 3 carbon present, odd number carbon, so it is this reaction is not suitable for preparing propane. Actually, there are some difficulties. If you want to prepare propane, for example, this is your ethyl chloride. When it reacts with sodium metal, and suppose this is methyl chloride, I mean I have taken different haloalkane, reaction will take place. So one haloalkane I have taken ethyl chloride, another is methyl chloride. Here I have taken similar one, ethyl chloride, but here one is ethyl, one is methyl. Then when you carry out the reaction in presence of dry ether, then sodium combines with chlorine to produce sodium chloride. Then this CH3 CH2 combines with this CH3, it produces 3 carbon, I mean CH3 CH2 CH3, which is called propane. Okay, but in this reaction you don't get only propane, you will get some other product also. You will get butane also, CH3 CH2 CH2 CH3. You will get ethane also, CH3 CH3, and your side product sodium chloride you will get. I mean number of products of alkanes you will get. Your target is to prepare propane, but with propane you will get some amount of butane, some amount of ethane also. So this is the problem to prepare the alkane which contain odd number of carbon. Now why produce number of alkanes? They produce only one alkane, but here number of alkanes. Actually when the haloalkanes are different, one is ethyl chloride, one is methyl chloride, then this alkyl group combined with this alkyl group, they can prepare propane. Again in the reaction vessel, this alkyl group combined with this alkyl group, you can prepare butane also. 2 carbon, another 2 carbon, they can also combine to produce butane. Similarly, this alkyl group methyl combined with another methyl group, because they are present inside the reaction vessel. So methyl when combined, they can produce ethane also. But here ethyl when combined with ethyl, they produce butane. Ethyl when combined with another ethyl from its own molecule, then also it produces butane. Ethyl when combines with another ethyl group from its own molecule, it also produces butane. So there is no possibility to form other alkane. But when you take different haloalkane, when you take different alkyl halide, you will get different types of alkane. And that is why this method is suitable for preparing those alkanes which contain even number of carbon atom. So those alkane which contain odd number of carbon like propane, pentane contain 5 carbon, this type of alkane, if you want to prepare by applying this Wood's reaction method, then it is not suitable, because you will get a mixture of alkanes, and from a mixture it is very difficult to isolate one particular alkane. Your target is to prepare propane. Yes, ethane is produced, but with propane your butane, ethanes are also produced, and when they are mixing with each other, it is very difficult to isolate the propane from that alkane mixture. And that is why this method is not suitable for preparing the alkanes which contain odd number of carbon atom. And this is the drawback of this reaction. But this reaction is suitable for even number containing carbon alkanes. For that type of alkane it is suitable, but this method is not suitable for preparing the odd number containing carbon atoms. And that is why one question asks, why Wood's reaction is not suitable for preparing the alkanes which contain odd number of carbon atom. Then you have to write, to prepare odd number carbon alkanes, we have to take different haloalkane, and when we take different alkyl halide or haloalkane, then we will get a mixture of alkanes as product, and it is very difficult to isolate a particular alkane from the alkane mixtures. So that is why this reaction is not suitable for preparing the alkanes which contain odd number of carbon atom. So this is one of the method for preparing the alkanes. So thanks for today.